In this video, I will be providing the solution to 2022 JAMB Physics examination questions. For this video, we'll look at question 1 to 10. Question 1 here says, which of the following instruments is most appropriate in the measurement of the thickness of a piece of paper? Option A says spherometer, B, meter rule, C, micrometer screw gauge, D, vernier calipers. Now, for us this question is under measurement. For us to answer this question here, let's consider each of the options. Option A says spherometer. A spherometer is used to measure the radius of curvature of a sphere or curved surface. All right, so basically, we use spherometer to measure the radius of a sphere or perhaps a curved surface. Option B, there is meter rule. You want to know that meter rule is used to measure length, especially longer length. Option C says micrometer screw gauge. The micrometer screw gauge is used to measure length that are smaller. So while meter rule is used to measure lengths that are longer, micrometer screw gauge are used to measure length that are smaller. And then D, vernier caliper. The vernier caliper measures length and also diameter of an object. All right. So for this question here, we can say that the micrometer screw gauge is the most appropriate to measure the thickness of a paper. And this is because the thickness of a paper is very small. And the best instrument here to measure a small length, which in this case is thickness, would be the micrometer screw gauge. So the answer to this question here is C, micrometer screw gauge. Question number 2. The SVP of a liquid depend on its A, density, B, temperature, C, volume, and then D, pressure. To answer this question here, the first thing we have to do is to understand the meaning of SVP. Now note that SVP simply means saturated vapor pressure. All right. So I'm going to write this. SVP is simply saturated vapor and then pressure. So basically, this is what you have as SVP. Okay. A saturated vapor pressure, what it means is that it's simply a vapor that is in contact with its own liquid within a confined space. All right. Now, let's say I have a liquid in, let's say, a jar or something like this. I have a liquid here, or let's use this better still. Say I have this here. So I have this, and then we have a level of water, right? This is the liquid here. And for some reason, I choose to, when we say confined space, I mean a closed space. I use something to close up this place here. So you have this. So this part here is closed. You'd agree with me that for this particular liquid here, if I heat this liquid, that set this on fire, right? If I heat this, the water vapor here would want to evaporate to the atmosphere. Now, in a case where the space is being confined, that's covered, and the water vapor cannot escape, what happens now is that the water vapor here will be in contact with what there? The liquid. So you have the liquid here and you have the vapor here. This vapor is what is called the saturated vapor pressure, all right? A kind of vapor that is in constant contact or in contact with its own liquid within a confined space. Now, what you want to understand here is that for this thing here, for this vapor here, the more I increase the heat, right? If I increase the heat, what happens to this? You see that the more I increase the heat here, the more I'll have more water vapor going upwards here. And of course, you have more water vapor here. So in essence here, the amount of water vapor I would have at the top or in the confined space depends on how much I heat this. And when we say heating, what comes to mind is what there? Temperature. So that means for this question here, the SVP of a liquid depends on its, the answer there is B, temperature. That's your answer. Number 3, in a pure inductive and capacitive circuit, where is all the energy stored when the current is at peak? All right. You want to take note that they said when the current is at peak. That's the condition. A, in both the inductor and the capacitor. B, in the capacitor. C, in the entire circuit. D, in the inductor. So this is a question under circuit, all right? AC circuit. Now, how do you answer this question? They mentioned two things here. They said inductive and capacitive circuits. What we say an inductive circuit, as you have here, is simply a circuit that contains an inductor. When we say capacitive circuit, a capacitive circuit is simply a circuit that contains a capacitor. Now, having noted that you have inductor and capacitor, you should note that an inductor stores energy in magnetic field. All right, take note. An inductor, an inductor stores energy in magnetic field. And also, a capacitor stores energy in electric field. So while inductor stores energy in a magnetic field, a capacitor stores energy in an electric field. Now, when current is maximum, the energy is stored in the inductor. So when current is maximum, energy is stored in the inductor. Please take note of this. Right? So when current is maximum, the energy is stored in the inductor. Meanwhile, when current is at zero, so when I is zero, let's call it zero, it is stored in the capacitor. Stored in capacitor. Okay, to take note of this. So hence, from the question here, they said in a pure inductive and capacitive circuit where all the energy is stored, where is all the energy stored when the current is at its peak? By peak, they mean what there? Maximum. And from here, we said the answer is what there? Inductor. So at its peak or at its maximum, the energy is stored in the inductor. So take note, that's D. Meanwhile, when the current is zero, it will be what there? In the capacitor. So please take note of this. Question number 4, the SI unit of moment of a force is dash. You have these options here. The first A is kilogram meter, B is micrometer, C is joules meter, D is micrometer. So you can see that micrometer is being repeated. But then what's the answer to this question here? The question here is to find the unit of this moment of a force. And if you recall, moment is equal to what there? Force times perpendicular distance, or basically force times distance. And if that's so, force is measured in Newton, distance is measured in meters. So the unit should be Newton meter. So I guess you have micrometer and micrometer. One of these should have been Newton meter. So let me just take B instead. I'll correct B to be Newton meter. It could be an error from the publishers. So the answer there, let's take B, Newton meter. That's a unit, okay? Force times distance. Question number 5, the product PV, where P is pressure and V is volume, has the same unit as A, impulse, B, power, C, force, D, work. Let's look at PV, all right? Let's look at the product PV. Now, when we say PV, product of P times V, and we said it's equal to PV, they said P is simply pressure. We know that pressure is equal to force all over area, right? Times V is volume. So we have volume. Let's bring in the SI units. If you bring out SI units here, this is equal to force in Newton all over area is measured in meter square times volume is measured in meter cube. From here, you can see that meter squared will cancel itself here. 1. There are 3 of this. So if I remove 2 from here, that's meter squared divided by meter. You have meter. So if you multiply this, so meter cube divided by meter squared, you have meter. Multiply this, Newton times meter gives you Newton meter. The question now becomes, which parameter has an SI unit of Newton meter? Newton is the unit for force, so you have force. Then meter is the unit for distance, so you have distance. So if you have force times distance, which parameter is force times distance? The answer is what there? Work done or work. So work or work done becomes the answer to this question. This is under units, right? Units and dimensions. All right, so let's see. Do you have work done? Yep, that's D, option D, work or work done. That's the answer. Question number 6. Which of the following is an advantage of a thermoelectric thermometer? A. It is not suitable for measurement of rapid changes in temperature. B. It is sensitive. C. It is very fragile. D, it is not very accurate. So how do we solve this question here? Now, let's note something about a thermoelectric thermometer. Thermoelectric thermometers are used for measuring very high temperature, and they work on the principle of the thermocouple. Now, there are some advantages of the thermoelectric thermometers. It includes number one, it is very sensitive and can measure rapid temperature change. Number two, it is used to measure high temperature up to 500 degrees Celsius. Number three, it is very small in size and can therefore measure temperature almost at a point. And if you look at this, so from what we said earlier, from what we've said so far, you can see that the answer here is B, that it is very sensitive and can measure rapid change in temperature. So that's the answer to question number 6. Question number 7 says, what is the energy of a radiation that has a frequency of 8.2 times 10 to the power 16 hertz? You have H there, right? H is Planck's constant, equal to 6.67 times 10 to the power, I think it should be minus 34 joules, right? Not 134, minus 34. Planck's constant is a constant, so times 10 to the power minus 34 joules, right? We have to find the energy. Now, how do we solve this? To solve question 7 here, you have to recall a formula. So for question 7, recall the formula for 7. Recall the formula that energy E is equal to the product of Planck's constant and frequency. You said H is called Planck's constant, P-L-A-N-K, Planck, all right, or Planck's constant. All right, let's put in values. This is equal to Planck's constant here, as you're given, is 6.63 times 10 to the power minus 36. So this gives you 6.63 times 10 to the power minus 36. This multiplying frequency. What's the frequency here? The frequency here is 8.2 times 10 to the power 16 hertz. I'm having this as 8.2 times 10 to the power, this to the power 16 hertz. So you have this. Now let's multiply this. I'll get my calculator and punch this real quick. Let's see this, 6.63 times 10 to the power minus 34. This times 8.2 times 10 to the power 16. To the power 16. When you punch this, the answer here is 5.44 approximately times 10 to the power minus 17. Of course, this is energy. For energy, the SI unit is what there? Joules. So let's see which option has this. 5.44 times 10 to the power minus 17. So there's 5.44 times 10 to the power minus 18. So I guess that should be option A, but they wrote 7, so it should have been 17. Again, maybe a typo error. To the power 17 minus 17 joules. So I'll correct this to minus 17 joules. So the answer there is option A, 5.44 times 10 to the power minus 17 joules. That's the answer. All right, question number 8. For question 8, they said the diagram below shows the application of a diode in A, full wave rectification, B, reverse bias, C, half wave rectification, D, forward bias. Now, how do we solve this question here? To answer this question, you have to note something. Now, considering this diagram here, right, they said something about a diode, right? Now, for the diode, you want to know that this part here, when you have this, right, when you have this, let me draw this better. When you have this one here, and then this, you want to note that this part here is a negative part called the cathode. Why this part here, all right, with the arrowhead is a positive part called the anode. Now that's for the diode here. If you come to the battery, that's this part here. Let's pick out the battery. That's, you can see this way. The longer part is at the left, the shorter part is at the right here. Now for the battery here, this part is the negative part of the battery, the shorter part, while the longer part is the positive part of the battery. If you look at the connection, you can see that the positive part of the diode is connected to what there? The negative part of the battery. Look at this. Positive part of diode is connected to the negative part. So this is positive part of diode, negative part of battery. Also, this other way too, the negative part of the diode, you can see this way here, is connected through up to the positive part of the battery. So here's what you need to note. This diagram here shows the application of a diode in reverse bias, right? In a reverse bias, what happens is that the positive terminal of the diode, as you can see here, is connected to the negative part of the battery and vice versa. And this is for rectification. A resistive diode is needed, which is not in this diagram, right? So actually we need a resistive diode, but it's not in this diagram. So for this question here, the answer becomes reverse bias. So the answer is option B, reverse bias. Okay. Question number 9. At what frequency Question number 9. At what frequency will a 12.0 millihenry inductor have a reactance of 880 ohms? You have your option A, B, C, and D. So how do we solve this question here? In this question, this is a question under reactance or AC circuit, right? The reactance of a frequency or an inductor circuit, please. A reactance of an inductor circuit. Now let's recall our formulas. So question number 9. Let's recall formulas. Recall that for an inductor circuit, the reactance is given by XL. So reactance is X, while L shows you inductance or inductor, right? So reactance of an inductor, XL, the formula is simply equal to 2 pi FL. That's the formula, all right? If they said at what frequency? So you're asked to find the frequency. Will a 12.0 millihenry, the Henry you see here is the units for inductance. So it gave you L, inductance L, as equal to 12.0 or 12 millihenry. Okay. They said have a reactance of 880 ohms. So they give you reactance there, which is XL. So reactance XL of inductor is 880 ohms. That's this. All right, so they asked to find the frequency. Obviously, from here, if I'm to find frequency from here, you have that XL is equal to 2 pi FL. To get frequency, I'll divide here by 2 pi L, divide here by 2 pi L. 2 cancels 2, pi cancels pi, L cancels L. So you have F. So F is equal to XL, this all over 2 pi L. Let's put in values. The value of XL is 880. That becomes 880 all over 2 times pi is 22 over 7 or 3.142 times the value of L. Coming back to L, you can see that L is in millihenry. Convert this to Henry becomes 12 times milli is 10 to the power minus 3. That's the value of milli, all right? Then Henry. So in essence, the value of L here is 12. Since it's milli, 10 to the power minus 3. You have this. Okay. F is equal to, I'll put this in my calculator and punch this real quick. So this divided by 2 times 22 over 7, that should be in bracket, or pi, times, or you can type 3.142 times 12 times 10 to the power minus 3, showing milli. What I have here is 1167.36 in hertz. If you punch this correctly, you have this. If you look at the options there, that's for question 9. The options here are in 2 decimal places. So let me express this in 2 decimal places. F will be equal to, from here, I'll move this twice. So 1, 2, 3, 4. You have this. So I'm having 1 point. The next number there is 1. In 2 decimal places, I have 1, 2. After 6, the next number there is 7. And 7 is a plus 1. So 6 plus 1 gives you 7. So I have this as 1.17 times 10 to power. I had to move 1, 2, 3, 4 times. So 4 hertz. All right. So I have this. So let's see if you have 1.17 times 10 to the power 4 hertz. Let's see if you have that option. All right, so there's 1.17 times 10. There's no power there. Again, a typo error. So we'll pick any of the options we deem fit. Let's take this as option. Let's take B. 1.17 times 10 to the power 4. You could have minus 4 here, So we're taking the one that has 4, which is B. So that's the correct answer to this question. Question number 10 says, the greatest charge density. Question number 10 here says, the greatest charge density of the figure below is at point dash. A, 0.1, B, 0.2, C, 0.3, D, 0.4. Now, for questions like this, question number 10, you want to note that the greatest charge density is always at the pointed part, all right? The part that is most pointed usually has the greatest charge density. And by greatest charge density, we mean the most part of charge concentration. So charges would be much more concentrated at the part that has a sharp end, which is what there, 0.1. So the answer here is option A. That's the answer to this question. All right. Question 11 here says, calculate the force on a 5 meter long stiff wire carrying a current of 8 amperes and lying in a direction at 30 degrees to a magnetic field of magnetic flux density 0.6 Tesla. A, 30 Newton, B, 10 Newton, C, 12 Newton, D, 15 Newton. So how do we solve this question? The first thing you want to notice is that this question is under magnetic field. And for magnetic field, we said the force on a conductor carrying current, question number 11, the force on a conductor carrying current F is equal to I L B then sine theta. Okay, where I is current, all right? I is current. From the question here, the value of the current here is 8 amperes. That's 8 amperes. L is simply the length of the conductor or length of the wire in this case. And the value of the length, let's see how many, 5 meters long. So L is 5. B is your magnetic field, all right? And the value here is B is the magnetic flux density, all right? And the value here is 0.6 Tesla. So B is magnetic MAG flux density. And the value of B here is simply 0.6. It's measured in Tesla. So 0.6 Tesla, you have this. And then the angle theta is 30 degrees. So theta in this question is equal to 30 degrees. Let's use the values here. From here, the force F will be equal to I, 8 times L, 5 times 0.6. So 8 times 5 times 0.6, this is in meters. 8 times 5 times 0.6. Then sine of the angle there is 30. Okay, so F is equal to, let's multiply this. So I'll get my calculator. I'll punch 8 times 5 times 0.6 times sine of 30. My answer here is 12. So this becomes 12. Don't forget that F means force, and force is measured in Newton. So you have this. So the value here, F, is equal to 12 Newton, which is option number C. So we have this. Okay. Next up, number 12. 12 says, which of the following is correct about an electric cell? A, primary cell produces a large current for a long time. B, secondary cell has a very high internal resistance. C, primary cells have a very low internal resistance. D, secondary cells have a very low internal resistance. Now you want to note this about electric cells. Let's start with primary cells. Primary cells are used up gradually. Often the cells are used and can't be recharged. All right, so primary cells can't be recharged. Meanwhile, secondary cells or accumulated can be recharged and used for a long period of time. and their main advantage is that they have very low internal resistance. So in essence, secondary cells have very low internal resistance, which is D. So the correct option here is option D, that secondary cells have very low internal resistance. Okay, question number 13. Which of the following operations can be used to convert an alternative current dynamo into a direct current dynamo? A. Number of turns in the coil is increased. B. Strength of the field magnet is increased. C. Slip rings are replaced by split ring accumulator. D. Coil is wound on a soft iron armature. Now, what's the answer to this question? Now, this question here is under DC generators. Here's something to note. A DC generator is one in which its current is allowed to flow in one direction, even though it may vary in value. Meanwhile, an AC generator can only be made to produce a DC by replacing two slip rings with a single split ring or accumulator. So the answer here would be option C. All right. The slip rings are replaced with split ring accumulator. That is the correct option. Question number 14. The net capacitance in the circuit above is, we want to find the equivalent or net capacitance here. How do we solve this? Now, for this question here, you'd have to resolve this to a single capacitor or capacitance. You have three capacitors here, 1, 2, and 3, right? This having 2 microfarad, this having 2 microfarad, this having 4 microfarad. Now, how do you resolve this? You start with these two, 1, 2. Of course, they're in parallel. So resolve them in parallel, take the answer, and resolve this in series. So let's resolve. Let's call this C1. Let's call this C2. Let's call this C3. Now, how do you solve this? First, C1 and C2 are in parallel. So C1, this is question number what? Question number 14. So for question 14, you have that C1 and C2 are in parallel. All right, if they're in parallel, let's say this C1, this way. If they're in parallel, the equivalent C1 to C1, 2 is equal to C1 plus C2. So you want to note that capacitors in parallel is added straight up like this. The value here is 2 microfarad, 2 microfarad. That becomes 2 plus 2, same unit, that becomes 4 in microfarad. So the equivalent C of 1 and 2 is 4 microfarad. Now, this 4 microfarad here, if you resolve these two, you'd have it like this. So starting from this end here, you have this end. The value of C12, this is straight like this, straight. You have C12, which is 4 microfarad. That's these two resolved. Then you have this, which is this part here. Then you have C3. So you have this C3, and then you have this. You want to know that C3 is also this value here, which is 4 microfarad. So 4 microfarad. So from here, we can see that C12 and C3 are in series. So we can say also C12 and C3 are in series. How do we get the equivalence? For this here, we can see that the equivalent is given by 1 all over, that's the inverse of C net. So we have to find the net capacitance. That's equal to 1 all over C12. We'll take inverse plus 1 all over C3. All right. So this is how you find equivalence for capacitors in series. I have 1 all over C net is equal to 1 all over, this value is 4, plus 1 all over, this value here is 4. From here, I have 1 all over C net is equal to, if you sum this, 1 over 4 plus 1 over 4 gives you 2 over 4. So you take inverse. This one goes up, this comes down, becomes C net all over 1 is equal to, this goes up, 2 goes down. That becomes 4 over 2. So work on this from here. 2 here, 1, 2 here, 2. So the net capacitance is equal to 2 microfarad. The answer there is 2 microfarad. Let's see, that's option D, 2 microfarad. So you have this. All right. So this is how we solve this. You want to take note that the way we solve capacitors in parallel is opposite the way we solve resistors in parallel. I've explained that in our previous class. I'll leave a link in the video description. Question number 15. A body, when slightly displaced, is said to be in neutral equilibrium only if it tends to A. Come to rest in a new position with the center of gravity and height remaining unchanged. B. Return to its position. C. Remain in its displaced position. D. Move further away from its original position while its center of mass changes. Now, for question number 15, you want to note that if a body is slightly displaced for neutral equilibrium, it tends to come to rest in a new position. For such body to return to its original position, it is in stable equilibrium, and for it to remain in its displaced position, it means no displacement has occurred. If it moves further away from its original position, it is in unstable equilibrium. Hence, the correct answer for neutral equilibrium is that it tends to come to rest in a new position and the height remains unchanged. So that means the correct option here is A. It comes to rest in a new position and the center of gravity and height remains unchanged. That's the answer to this question. Question number 16. The instrument to measure the relative density of light is A. Thermometer, B. Hydrometer, C. Spring balance, D. Beakers. All right. Question 16. The instrument to measure the relative density of light is A. Thermometer, B. Hydrometer, C. Spring balance, D. Beakers. All right. Let's analyze each of these instruments one after the other. First things first, thermometer is used to measure the temperature of a body. The hydrometer is used to measure relative density of liquid. The spring balance is used to measure the weight of an object, while beakers is simply used to measure the volume of liquids in a lab. So they ask for the instrument used to measure relative density of light. The answer here is the hydrometer. So the answer there is B, hydrometer. Question number 17. The maximum kinetic energy of a simple pendulum below occurs when the bulb is at what position? So you have this. Now let's analyze this question here. Let's take this. So you have this. Let's say you have a ball here like this. If I choose to push this ball, right, with a certain speed, this ball goes up to a point. Let's call it point A. It goes up to point A. It stops at A. It comes back to this. Let's call this B. And from B, it swings to C. Let's call this C. Stops at C, swings back to B. Then from B, it goes to A. You want to note something. At point A, the ball stops moving. At this point here, A, this point here, A, the ball stops moving. Hence, its kinetic energy here is equal to what? There, 0. Again, it swings to B, then from B, it swings to C. At point C, what happens? It stops swinging and then starts coming back. That means at point C there, the kinetic energy is equal to what there? 0. But B is the part at point B. It's from B that it swings to A, and then from A stops, comes back to B, and from B it goes to C. In essence, B is the point that changes the direction from A to C. So this is where kinetic energy is maximum, right? So at B, kinetic energy is maximum. So the maximum is at the center there, which is 3. So for this question here, question number 17, the correct answer is option C, which is 3. That's this, all right? If they ask you the position for zero kinetic energy or the minimum kinetic energy, you have two positions, A and C, which in this case will be what there? 1 and 5. So 1 and 5 will have the minimum kinetic energy, Meanwhile, the maximum will be at the center, option B, which is number 3. Okay, question number 18. Let's look at question number 18. Question 18, from the diagram above, calculate, that's this one here below, in this case, calculate the total current in the circuit. So you have this. You have voltage, you have I, current, then you have 3 resistors, this one's here. You have to find the total current in this circuit. Now, how do we solve this? To solve this, your first task would be resolve these 3 here to give you 1 resistor. In essence, find the equivalent. The equivalent resistance here, question number 18. The equivalent resistance here, 1 all over R, is equal to 1 all over, since they are in parallel, I will take inverse. So 1 over 18 plus 1 over 12 plus 1 over 6. 1 over 18 plus 1 over 12 plus 1 over 6. Let's get this done. 1 all over R is equal to, so if I take my LCM here, my LCM here will be 36. 36. Now, 36 divided by 18 gives you 2. 2 times 1 here gives you 2, plus 36 divided by 12 gives you 3. 3 times 1 here gives you 3, plus 36 divided by 3 by 6 here gives you 6. 6 times the 1 above gives you 6. Working on this, I have 1 over R is equal to 2 plus 3 is 5. 5 plus 3, 5 plus 6 is 11. 11 all over 36. From here, for us to get the value of R, I'll simply take inverse. So if you take inverse here, this goes up, R goes up, 1 comes down. That becomes R over 1 is equal to 36 goes up, 11 comes down, 36 all over 11. So the value of R here is equal to 36 all over 11, of course, in ohms. So we have this already. Now, again, they said we should calculate the total current in the circuit. Let's get this in decimal places. So 36 divided by 11. If we punch that, 36 over 11, if you punch that, your value is 3.272. So this is 3.272 or 3, yes, approximately in ohms. So you have this. We have to find current. We are given voltage there. Recall that from Ohm's law, V is equal to I times R. To get the value of I, I'll divide and divide here by R divided by R. This cancels this. So current is equal to V all over R, and that's equal to, what's the value of V from the question there? It says 12 volts. So that becomes 12. So that becomes voltage 12 all over R. The value of R here is 3.273. Let's get this done. So I is equal to 12 divided by 3.273, and that gives you about 3.666, which is approximately 3.7. Current is in amperes. So let's see 3.67 or 3.7, any of them. All right, that's option B, 3.7 amperes. You have this. Question number 19. The volume of a fixed mass of gas is this 10 cm cube when its pressure is 40 centimeter mercury, that's cmHg. Find the volume of the gas when its pressure is 200 cmHg, which is centimeter mercury. Now, how do we solve this question here? To solve question number 19, we need to recall Boyle's law, right? So I'll take this off and let's solve this using Boyle's law. From Boyle's law, you want to recall that P1 V1 is equal to P2 V2. In 19, you were told that the volume of a fixed mass of gas is 10 cm cube. That means V1, which is this, is 10. So this is V1 cm cube. They said when its pressure is 400, so P1 is 400, so I'll have 400 here. So P1 400, V1 10. All right, let's proceed. It's equal to P2 V2. You ask to find the volume, that's V2, of the gas when its pressure is 200 cm. So you have when P2 is now 200, what's the value of V2 basically? All right. So to solve this question, just divide here by 200, divide here by 200, and let's get the value of V2. From here, V2 it's equal to 200 divided by 400, you have 2. 2 times 10, you have 20. So you have this as 20. The unit here is cm cube, because if you look at this, the volume here was in cm cube. Again, observe that we did not convert because this is in cm cube and this is in cm. So we didn't have to convert, right? The answer there is this one here, 20 cm cube. That's option D, 20 cm cube. All right, next up, question 20, the last one for today. The last one for this session. Question 20 says, under what conditions are cathode rays produced in a discharge tube? All right. A, high pressure and low voltage. B, high pressure and high voltage. C, low pressure and low voltage. D, low pressure and high voltage. For number 20, you want to note that cathode rays are produced in a discharge tube under low pressure and high voltage. And I think this is actually one of the most repeated JAMB questions. Okay, so you want to note that the correct option here is that cathode rays are produced in a discharge tube under low pressure and high voltage. So low pressure and high voltage is option D. That's the correct answer. All right. Question 21 says, for correcting long sight defects in the human eye, we require A, converging lens, B, diverging lens, C, microscope, D, periscope. Now you need to note that when they say long sight defects in person causes the person to see far or objects that are far but cannot see near objects. It is corrected with the aid of a converging lens in front of the eyes. So for this, the answer there is A, converging lens. Now this is under optics 21. 22, when two mirrors are placed at an angle of 90 degrees, so there should be a degrees here, angle of 90 degrees to each other, how many images will be formed when an object is placed in front of the mirror? So how do we solve this question? The option there, A, 5, B, 4, C, 3, D, 2. Now to solve this question here, you need to know the formula. This is for question number 22. For 22, you need to know the formula that the number of images formed, N, is given by the formula, or it's equal to 360 all over the angle minus 1, right? So that's a formula. Now with this, let's impute the value. They said when the angle, at an angle of 90 degrees, so that means theta is equal to 90. We'll have the N is equal to 360 all over theta is 90 minus 1. This is equal to, if you cancel this, all right, 36 over 9, you have 4. That becomes 4 minus 1. And from here, N is equal to 3. All right, so basically remember this formula, that the number of images formed would be equal to 360 all over the angle minus 1. So with this formula, our answer gives us N is equal to 3. So for this question here, the answer is 3. That's the answer. Next up, question 23. It is known that a neutron exists in a light atomic nucleus. Which of the following also exists in the nucleus? All right. You have A, an electron, B, a beta particle, C, beta particle, D, proton. I think B should have been alpha beta particle, perhaps. Anyways, D, proton. So what's the answer to this question? We'll talk about nucleus of an atom, right? You have this, right? You have this. Then you have electrons. You have something like this, where you have electrons revolving around the nucleus of a cell. and you have electrons, this revolving around the nucleus of a cell in orbit, right? For an atom here, what you have here is the electron. So the electron revolves around the nucleus of a cell. Now, inside the nucleus of a cell, which is this middle part here, let me bring this out here, this one here. Inside the nucleus of a cell, you have two things there. Number one, you have neutron. Number two, you have proton. So considering our option there, you can say that there's no neutron, but they mention proton. So in essence, for this question there, the answer is proton. But you want to know that the nucleus, the atomic nucleus, contains both proton and neutron. But since neutron is not here, we'll take just proton. So the answer there is proton. That's the correct option. Question 24 says, a string of length 5 cm is extended by 0.04 meters when a load of 0.8 kilogram is suspended at the end. How far will it extend if a force of 16 Newton is applied? You're asked to take G as equal to 10 meter per second squared. Now, if you're asked to find how far will it extend, what they're asking you for here is extension. They mention force, they mention extension. The question now becomes, which formula try to relate force and extension? And the answer there is Hooke's law. So this is question 24. From 24 there, question 24, remember that from Hooke's law, this is under elasticity. From Hooke's law, you have that F is equal to KE from Hooke's law. Now, coming back to the question there, let's pick out values. They said a string of length 5 cm. So you're given length L, it's equal to 5 cm. Perhaps we need to convert. Next, they said is extended by 0.04 meter. So extension E, it's equal to 0.04 in meters. Okay. When a load of 0.8 kilogram, so load, let's call the load force. So load or force are used interchangeably. 0. Let's see this again. 0.8 kilogram. But then you want to observe that this load is given in kilogram. In essence, what I have there is not a load but mass. So mass is equal to 0.8 in kilogram. Moving on, they said is suspended at the end. How far will it extend if a force of 16 Newton? Now, they give you a second condition here. They said force F is equal to 16 Newton. You're asked how far will it extend? Let's call this extension 2. Now, when you have this, the question would be, if I already have extension here, why do I now have, or why am I now asked to find another extension? That becomes the question. And if you want to look at this question here, observe that they said when a load of 0.8 kilogram here, this load here still represents a force. So all we have to do in this question, the first thing we want to do here is to, from here, you can see that in this first part here, what you're given here, you have the value for extension. Technically, you have the value for force because we can get force by saying force is equal to what there? Mass times gravity. You now see why you are given the value of gravity here, right? So let's get the force in this first part there. That means from here, force is equal to mass 0.8 times gravity, which you're asked to use 10, not 9.8. We're asked to use 10. So F is equal to 0.8 times 10 gives you 8 Newton. Now, in the first case, observe that I have the value for force and also extension. Let's get the K, the value of K, which is the constant. All right. Let's get the constant there. So we have that, recall, if F is equal to KE, to get the value of K, I'll divide here by E, divide here by E. This cancels this. So the constant there, K, is equal to F over E, which is 8 all over E, 0.04. That's this. So I have this as 8 all over 0.04, and that's equal to, so I'll get my calculator and try to punch this. 8 divided by 0.04, that gives about 200. That's 200 unit. Force is in Newton all over, extension is in meters. Look at this. So I'm having Newton per meter. And this constant remains the same, irrespective of a change in force. That means from here, now Now the constant remains the same irrespective of the change in force and extension. Now for the second case, I was given a second force. They said the force was now increased to what there? 16 Newton. And I'm asked to find the extension. How do you find the extension? From here, we'll have that F2 is equal to K times E2. Observe that I just use K. I didn't use K2 because K is a constant. From here, we can have that to get the value of E2, I'll just divide here by K and divide here by K. This cancels this. So the extension we are asked to find is equal to the value of F2, which is 16. So that's 16 all over K. The value of K here is 200. The value of K here is 200. So 16 over 200. Let's get this done. So 16 divided by 200. If I punch that correctly, my answer is 0.08. 0.08. The extension here is in meters. So my answer is 0.08 meters. I'll check which option has that. But before then, you want to observe that the value of L was given 5 meters or 5 centimeters, but we did not use it. All right. So you want to take note that we did not use it, but we did not even need to use it. So take note. All right. Let's see 0.08 meters. That's option D. That's the correct answer. 0.08 meters. All right. Okay. Next up, question number 25. Question 25 says, what is the speed of a body vibrating at 50 cyclic, it should be cycle, 50 cycle per second, right? What is the speed of a body vibrating at 50 cycle per second, right? How do we solve this question? What do we do? Now, here's what to note. To solve this question, you need to note something. And note that when you say 50 cycle per second, note that one cycle, right? One cycle per second is equal to 2 pi rad per second. Okay, now having this, with this particular relationship, you can now solve this question. So if one cycle is 2 pi rad, they're not asking you 50 cycle. 50 cycle per second will be equal to unknown. All right. But before you solve this question, don't forget this particular relation. This is what you need. That one cycle is 2 pi rad per second. And the simple reason is because when we say one cycle is 360 degrees. All right. If I go through one cycle like this one here, the total angle there is what? 360 degrees. And we also know that the value of pi, when it comes to angular measurement, pi is equal to 180. Of course, 180 times 2 gives you 360. So when we say 2 pi, it means 2 times 180, which is what there? 360. So that's how we derive this formula. Okay. Now, at this point, we know that one circle is equal to what there? 2 pi rad per second. 50 circle, it becomes x. All you have to do here is cross multiply. X times 1 gives you x is equal to 2 pi times 50 gives you 2 pi times 50, and that's equal to 100 pi, right? And then the unit becomes the unit of this part here, which is rad per second. So the correct answer here is 100 pi rad per second, and that is option A. Next question, question number 26. 26 says, which of the following is not part of the electromagnetic spectrum? That is question number 26. All right. A, alpha particle. B, gamma ray. C, infrared ray. D, radio waves. So which of this is not part of the electromagnetic spectrum? Now, here's what you want to note. Note that the electromagnetic spectrum is a whole range of electromagnetic waves, which includes gamma rays. So gamma rays is there. Number 2, UV light. Okay, or number 2 is visible light. All right. They also have number 3, microwaves. You have number 4, radio waves. You have number 5, X-rays. You also have infrared. You also have UV rays. So with all of this mentioned here, you want to also note that alpha particle is not part of it. All right. Gamma rays has been mentioned, is there. Infrared rays there. Radio wave is there, but alpha particle is not there. So alpha particle is not part of the electromagnetic spectrum. All right. Okay. Question number 27. It says a cell of internal resistance 2 pi supplies current to a 6 pi resistor the efficiency of the cell is A, 12.0%, B, 25.0%, C, 33.3%, D, 75.0. I guess there should be a percent here. Okay, so how do we solve this question here? For 27, you want to note that the internal resistance determines the maximum current that can be supplied to a particular cell, all right? And for this, the formula we use for this 27, the formula 27 is that the efficiency, this is equal to small r all over capital R times 100%, all right? And from this, the value of small r is simply the internal resistance, the value of the internal resistance, right? That's the value of small r, while the capital R is the other resistor here, which is this one. So this internal resistance is your 2 pi, so it becomes your small r. This is equal, efficiency is equal to 2 pi all over the external resistance, which is 6 pi, as we have, times 100%. Working on this is equal to pi cancels pi, 2 here, 1, 2 here, 3. So I'm having 1 over 3 times 100. So 1 times 100% gives you, 1 times 100 gives you 100 all over 3%. 100 over 3 gives you 33.33333%. So my answer here is 33.3%. Let's see which option is that. That's option C, 33.3%. Okay, question 28. 28 says the distance between the image and the object in a plane mirror is 40 cm. If the distance of the object is reduced by 9.2 centimeters, what is the distance of the object from the mirror? That becomes the question. So how do we solve this particular question? What do we do? The first thing we want to notice here is that they give you something called a plane mirror. And let's analyze a plane mirror a bit. This is question number 28. 28 here. Let's analyze a plane mirror. So let's say I have a ground level this way. All right. Let's say I have a ground level this way. And I have a plane mirror this way. So I'll call this plane mirror. Plane mirror. If a person comes here and stands this way, right? A person, let's call this a person here. Person. If a person stands in front of a mirror from this point to this point here, let's call this distance A. The person's image, let's call it this here, the person's image. Oops, the image is bigger than the person. Haha. All right, let's reduce this. Let's try to get the same height, at least. Okay, something here. See, the person now has a bigger head. Oh my God. All right, please just manage my diagram, okay? Okay, so I have this. Here's what to note about a plane mirror. When a person stands in front, this is the back of the mirror, and this is the image. When a person stands in front of a plane mirror, the distance between the person and the mirror, as you can see, A, would be the exact same distance between the mirror and the image. So hence, for one of the most unique thing about a plane mirror is that the first thing you want to notice is that this distance between the object, which is the person here, from here to the mirror, which we called A, is the same thing as from the mirror to the person's image. Of course, the image is formed behind the mirror. That's the first thing you want to note. The second thing you want to note is that a plane mirror gives you the exact same size or the exact size of the image. That means the image would look exactly like the object or the person. There is no increase, there's no decrease, there's no magnification, and there's no diminishing, just the same. Now, coming back to the question here, they said the distance between, note that they said image and object. Distance between the image and object in a plane mirror is 40 cm. So from the image, where is the image? The image is the person. So from the person here to the object. All right, so where's the image? Here's my image here. Where's the object? The object is the person. That means from here to here, right? It's about 40 cm. 40 cm. If it is 40 cm, that means distance from this point to this point, to the middle point here, 20 cm. That means the person is 20 cm from the mirror, while the person's image is 20 cm from the mirror. All right, so we've gotten this part here. All right, 40 cm between the object and the image, so 20 cm both of them from the mirror. They now said if the distance of the object is reduced by 9.2 centimeters. The question is this: if I want to reduce the distance of the object, does the object move closer to the mirror or away from the mirror? Obviously, if this man goes away from the mirror there, the distance will increase from 20 to perhaps 25, so an extra 5 centimeters. So that will be increasing. But if I want to reduce the distance, all I have to do is simple. I'll move the man towards the mirror. That's the concept. Now let me show you this real quick. If this man moves towards the mirror here, let's say to this point here, like this, you want to observe that from here to here, that's this point here, will be less than 20. You want to know that if I want to reduce the distance of the object, I have to bring the object closer to the mirror. That's the concept there. Now, they said if the distance of the object is reduced by 9.2 centimeters, that means this object or this person came closer to the mirror by 9.2 centimeters. So 9.2 centimeters. Now, if this is the case, the question will now be, what will now be the distance? What's the new distance of the person or the object to the mirror? What is this new distance here? We know very well that the distance, let's call this point A and let's call this point B. From A to B is about 20 cm, but this man moved towards B, that's the mirror, by 9.2 cm. So what is the distance left? Let's call it X. To get the distance left, it means 9.2 plus X is equal to what there? 20 cm. So let's find that 9.2 plus X is equal to 20 cm. X becomes 20 minus 9.2. So X is equal to 20 minus 9.2. And if I do that, my answer here is 10.8 cm. That means the object now has a distance of 10.8 centimeters. So 10.8. And it makes sense because we said the distance was reduced. So it now has to be a lesser value, which in this case is 10.8. What's the question there? The question says we should find what is the distance of the object from the mirror. So the answers to this question should be a 10.8 centimeters. This is the correct answer. Unfortunately, the correct answer is not here. So note that the answer is equal to 10.8 and actually in centimeters, not meters. Right? It's in centimeters, not meters. The option here is still wrong. Meters, 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 which even shows further that this is wrong. And if you're good with optics, this is actually under optics. If you're good with optics, you note that for optics, the units are usually in centimeters, not meters. So the actual or the correct answer there is 10.8 centimeters. All right, just follow myself in here. That's how it's done. All right, next up, question number 29. 29 says the phenomenon of radioactivity was first discovered by A. Marie Curie, B. J.J. Thomson, C. Henry Becquerel, D. Enrico Fermi. The correct answer here is Henry Becquerel. Right, so take note that Henry Becquerel discovered the concept of or the phenomenon of radioactivity. All right. Question number 30. 30 says, in the figure above, that's this one below actually, V is the viscosity and U is the upthrust. Which of the following equations holds when the falling body P has attained a terminal velocity? All right. When the body attains terminal velocity, which of this equation holds? Now, to solve this question, it's very simple. We'll bring in the equation for equilibrium. For equilibrium, we know that sum of forces going upwards is equal to sum of forces coming downward. That's all. The forces going upwards are U and V. So sum of forces going upward, V plus U or U plus V. Let's take V plus U is equal to sum of forces coming downward. Coming downward is just mg. So it becomes is equal to mg. So I have this. This is what is needed for equilibrium or for the object to attain terminal velocity. And if I move mg to the left hand side, I'll have v plus u plus mg becomes minus mg, and that'll be equal to nothing here, so it becomes 0. So let's see which option that is. That's option B. V plus u minus mg is equal to 0. That's your correct answer. Question 31 says, which of the following is a semiconductor? Now you want to know that this is actually one of the most popular questions in JAMB Physics. And when we talk about semiconductors, two things come to mind basically, or the two most common examples are silicon and germanium, right? So if they ask you for semiconductors, it's usually either silicon or germanium. So looking at this, without even having to stress myself, you can see that the answer there is B, silicon. Okay. You also want to, as I said earlier, you want to take note that the other example they almost always give is germanium. All right, so you have this. Okay, let's move on. Question 32 says, when two objects P and Q are supplied with the same quantity of heat, the temperature change in P is observed to be twice that of Q. The mass of P is half that of Q. The ratio of the specific heat capacity of P to Q is A 1 is to 4, B 4 is to 1, C 1 is to 1, D 2 is to 1. So what is the correct answer here? Now to solve this question here, they mentioned something about specific heat capacity, they mentioned mass, they mentioned temperature. Now the formula that relates all of this for 32, the formula that relates all of this is given by H being equal to mc theta, right? So H is equal to mc and theta, where H is simply heat energy. So heat energy, M is simply mass, of course, heat energy in joules, right? M is mass, that's in kilogram, all right? C is specific heat capacity. C is specific heat capacity, and then theta is simply your temperature. All right, so you have this. Now, with these conditions here, looking at the question again, they said two objects P and Q are supplied with the same quantity of heat. All right, so when we say the same quantity of heat, is simply the same heat energy. So I'm saying that the heat energy H in P is equal to heat energy H in Q. And if this is true, let's try to see how we can relate this. H is equal to mc theta. That means m of P, c of P, theta of P. It's equal to the same thing for Q. That's m of Q, c of Q, then theta of Q. We have this. Okay, proceeding, they said they are supplied with the same quantity of heat. So this is why I equated them. I equated HP to HQ because we have the same quantity or amount of heat. The temperature change in P is observed to be twice that of Q. That means temperature of P equal twice that of Q. So theta P is equal to 2 times theta Q. That's the first thing to note. They also said the mass of P is half that of Q. So mass of P, let me call this MP, is also equal to half. Let me use 0.5, 0.5 mass of Q. All right. Next up, you have to find the ratio of the specific heat of P to Q. So I'm looking for CP over CQ, basically. P over CQ, right? Ratio of specific heat of P to specific heat of Q. Now, how do I solve that? From this equation here, let me put in values. If I should convert this, we said you have MP, right? So I'm having this as MP, and let's try to relate this in terms of, they said C to P. So from here, all I have to do is to find a way to get the ratio or the fraction CP over CQ. And how do I do that? From here, all I have to do is simple. I have MP CP theta P is equal to MQ CQ and then theta Q. How do I get CP over CQ? Divide here by MP theta P. Divide here by MP theta P. This cancels this cancels this. So we'll have that CP from here. So from here, we'll have that CP is equal to MQ CQ theta Q all over MPQP. Again, still on this, to bring it mathematically correct, to just bring CQ, that's this downwards like this, it's mathematically correct. So what I'm trying to say is this: I can have that CP all over CQ is equal to MQ theta Q all over MP theta P. So it's mathematically correct to bring CP down here as a denominator because this is all over 1. So it's CQ times 1 here. That gives you this. So this was the relationship we asked to find. So the ratio of the specific heat of P to the specific heat of Q is given by this formula. Let's now bring in their relationship. We said theta P is equal to 2 times theta Q. So, and we also said that MP is equal to 0.5 MQ. So this is equal to MQ theta Q all over MP 0.5 MQ. So this becomes 0.5 MQ. That's the value of MP multiplied by theta P. Look at this. Theta P is equal to 2 theta Q. So I'll replace this theta P here by 2 theta Q. From here, MQ will cancel MQ. Theta Q will cancel theta Q. Numerator, I have 1. Denominator, I have 0.5. That's half times, dot means times 2. That gives you 1. So in essence, what I'm seeing here is simply 1 divided by 1. And 1 over 1, as we know it, in terms of ratios, is 1:1. So the answer there is 1:1. So let's see if we have the option there. Yep, that's option C, 1:1. That's the option. Okay, let's move on. Question number 33. An element and its isotope only differ in the number of course, for isotopes are simply elements that have the same number of protons but different number of what? Neutrons. So the simple answer here is neutrons. All right, so they differ in the number of neutrons. That's the correct answer. Question 34. Which of the following statements is not correct? A. Molecules of a liquid are stationary. B. Brownian motion is an evidence of the particle nature of matter. C. Matter is made up of molecules. D. The molecules of matter are in constant motion. Now we know that D is correct, right? Molecules of matter are in constant motion. C is also correct because matter is made up of molecules. Yes, that's correct. Then B, Brownian motion is an evidence of the particle nature of matter. That's also correct. A says molecules of a liquid are stationary. Well, for a liquid, the molecules of a liquid are not usually stationary except it is being frozen, right? So on a normal case, right, at a normal temperature, the liquid molecules are always moving. So hence, the answer is A. A is not correct. So we have this. 35. The equation PV equal to constant, PVT equal to constant in Boyle's is Boyle's law, not in Boyle's law, right? So is Boyle's law if now for Boyle's law we know that PV is equal to K. That's Boyle's law. But here they give us PVT is equal to constant. So if I'm giving PVT equal to constant, how do I eliminate or how do I make this Boyle's law? Of course, this should be P to power X V to power y, t to power z. This is how it should be, right? The equation p to power x, v to power y, t to power z equal to constant is Boyle's law. If, of course, P has to be, if I want to get PV equal to constant, the power of P here should be 1, yeah? The power of V here should be 1, and there should be no T. So if I have T to power Z, and I don't want T, what do? I need to raise T to power what there? 0. Because T to power 0 gives you what there? 1. And 1 times PV gives you what there? PV. So since T does not exist, we'll put the power 0, P to power 1, V to power 1, T to power 0. So it means X is 1, Y is 1, Z is 0. So let's find that option there. X1, Y1, Z0. That's option C. X equal to 1, Y equal to 1, Z equal to 0. That's your correct answer. Moving on, 36. Which of the following is a scalar quantity? A. Tension. B. Weight. C. Impulse. D. Mass. For this, the correct answer, simple enough, is mass. Mass is a scalar quantity, all right? Tension is a vector quantity. It acts usually upwards, all right? B. Weight. Weight acts downward. Then you have impulse. So the answer there should be mass. Mass is a scalar quantity. 37. Which of the following instruments helps to maintain the correct humidity and temperature of a building? A compressor. B, a refrigerator. C, air blower. D, air conditioner. Very simple question. The answer there is D, air conditioner. All right. Question 38. A waterfall is 420 meters high. Calculate the difference in temperature of the water between the top and bottom of the waterfall, assuming no heat is lost. Take the specific heat capacity of water to be equal to 4.20 times 10 to the power 3 joules kilogram, right? Where joules per kilogram. Take the specific heat capacity of water to be equal to 4.20 times 10 to the power 3 joules kilogram per Kelvin. And then G, that's acceleration due to gravity, as 10. Then take G to be equal to 10 meter per second squared. So this should be 10 meter per second squared, because what you have here is acceleration due to gravity. All right, so how do we solve this question here? In this question here, they said a waterfall is 420 meters high, so 38. You're given height H as equal to 420 meters. They said calculate the difference in temperature. So you're looking for difference in temperature, which is theta, or change in theta, between the top and bottom of the waterfall, assuming no heat is lost. They give you specific heat capacity of water, that's C. This is C. They gave you C as being equal to how many there? 4.2. 4.2 times 10 to the power 3 joules kilogram per Kelvin. Okay, what else? They said take G to be equal to 10, this is 10 meters per second squared. We are asked to find change in temperature. Now, for this question here, let's see, were you giving the mass? Are you giving the mass here? Nope. For this question here, let's recall the formula we need for this question. Recall that for this question, that when it comes to heat energy, H is equal to mc times theta. So if you're asked to find the change in temperature, you're asked to find the value of what there? Theta. For us to find theta, we need the value of H, which we have. We need C, which we have, but we don't have the value of M. It's not given. But then you want to note something. There's something we need in solving this question. They said a waterfall is 420 meters high. So water is falling from a height. So you have this height here. And they said no heat is lost. In this concept here, you need a concept of energy conservation, which says that energy is not lost, but is being converted from one form to another form. That's the concept here. And that's why you're saying, and that's what they asked, or that's why you're told to assume that no heat is lost, because we said energy is not lost, but it's converted from one form to another. So in this case here, we have heat energy. If heat is not lost, what form is it converted to? They said it is falling from this height, a height of 420 meters. Okay, and when we talk about height there, the energy possessed by a body due to its position or its distance or its height is actually potential energy. So if heat is not lost, it means that it's converted from heat energy to what? The potential energy. And we record that potential energy P is equal to what? The mass times gravity times height. That's what you have. In essence, we are converting heat energy H to what? The potential energy. Heat energy is M times C times, they said change in temperature. So I'll just call this change in theta, or you can just say theta. It's still the same thing. It's equal to, for P, you have mass times gravity times height. Looking at these two things here, you can see that mass can easily cancel. You have to find the change in temperature, which is change in theta. To get that, you divide here by C, divide here by C. So change in theta is equal to G times H, all divided by what there? C. G, as we have it there, is gravity. That's 10. All right, that's 10. Let me write this somewhere else. So G times H over C. All right, let me just write it here. Change in theta is equal to G times H, all divided by C. G is 10 meter per second squared times H. What's the value of H? The value of H is the height there, all right, which is 420. Please, the H here, recall that the H was from mgh, mass times gravity times height. This H here, not heat. All right, please take notes. All right, perhaps I should have used a small h, but whichever way, this is 420, as we had, meters all over. The value of C from the question, let's see, 4.2 times 10 to the power 3. This is 4.2 times 10 to the power what there? 3. You have this. So let's punch this. I will get my calculator and punch this very correctly. So I'm going to do, let's say this. So hang on. 10 times 420, all divided by 4.2 times 10 to the power 3. If I do that, the value there is 1. So I have this as 1. So I have this, my answer here as 1. All right, so let's see which option there. All right, looking at this, consider the option there is 1.0. So A, 1.0 or 1. That's your answer, all right? Okay, question number 39 says three ohm resistors, or that should be resistors, are connected in parallel. What is the equivalent resistance? Right? When we have resistors in parallel, we have that the equivalent. So 39, when we have resistors in parallel, we have that the equivalent is given by 1 all over, let's call R as the equivalent, is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So I have 1 all over, the equivalent is equal to, they said 3 ohm. So each of them, R1 is 3 plus R2 is 3 plus R3 is also 3. Each of them is 3 ohms. This is equal to, if I have the same denominator, 3, I'll just bring that here, then add up numerator. 1 plus 1, 2, 2 plus 1, 3. So I have this. So I have 1 over R is equal to 3 over 3. From here, I'll have 1 over R is equal to 3 cancels here, 1, 3 cancels here, 1. That becomes 1 over 1. From here, cross multiply. R times 1 gives you R. It's equal to 1 times 1 gives you 1. So the value is 1 ohm. So I have 1 ohm as my answer. Coming back to this, all right. So the answer is this 1. That's the correct answer. Let's look at question 40. A man of mass 50 kilogram ascends a flight of stairs 5 meters high in 5 seconds. If the acceleration due to gravity is 10 meter per second squared, the power expanded is A, 100 watts, B, 200 watts, C, 400 watts, D, 500 watts. So how do we solve this question? Let's look at question 40. You're asked to find the power expanded. Let's recall formulas that power is equal to the rate at which work is done, which is simply equal to work done, or work, or let's just say work done, all over time. That's why we call it the rate at which work is done. Work done, on the other hand, work done is equal to force times distance. Again, force, as we know it, is equal to mass times acceleration or gravity times distance. So work done is simply mass times gravity, which is force, times distance. And if you put this in context, it means that power, P, is equal to mass times gravity times distance, because all of this represents work done all over time. So we have this. Let's impute value. What is mass times gravity? The mass is 50 kg. So 50 times the gravity, which in this question is 10, times the distance. In this question, what's the distance here? They said 5 meters high. So times distance 5 all over time. The time in this question is what there? 5 seconds. So all over 5. So let's solve this. From here, obviously 5 cancels 5 here. So it's gone. And that becomes 50 times 10. 50 times 10 gives you 500. You're asked to find power. Power is measured in watts. So I have my answer as 500 watts. So let's see which option that is. That is option D, 500 watts. So this is the answer to question number 40. Question number 41 says, calculate the upthrust on an object of volume 50 cm cube, which is immersed in liquid of density 10 to the power 3 kilogram per meter cube. Take G as equal to 10 meter per second squared. Now, how do we solve this question? The first thing we want to do is to identify the parameter in question. The question here said we should calculate the upthrust on an object. You want to note that upthrust is simply a force that acts on an object when it is being immersed. By immersed, we mean put inside a liquid. So here's the thing. If I have a bucket of water, something like this, or a bowl of water like this, of course, containing water, this, and I have a ball here. If I put this ball inside the water, so bring this down, right? If I immerse this ball in water like this here, of course, the ball will be going downward. There is a force that will tend to act upward. Of course, according to Newton's third law of motion, to every action, there's an equal and opposite reaction. So the force that acts opposite of this ball that is being immersed in this water is called the upthrust. All right. There are other forces that could act, such as the viscosity of the fluid. But for now, let's focus on upthrust. Now, with this being said, the key thing you want to note here is that upthrust, as we said, is a force that acts in the opposite direction, that's upwards, of an object being immersed inside a liquid. So the idea is this, that upthrust is actually equal to or is a force. So force here. That's what you want to note. And of course, it's measured in Newton. Now with this, let's recall something. Let's call upthrust. Let's call this U. So U, upthrust, is equal to, for force, the unit for force can be given by mass times gravity. We're using gravity here because the object is being immersed vertically downward. So when an object is being immersed vertically downward, we don't readily say F equal to ma. No, we replace A with what there? G. Why? Because the body is moving what there? Vertically downward, which is this way, vertically downward. Now with this said, so force, the force here becomes mass times gravity, or M times G. Again, because we're dealing with density and liquid here, want to recall that density, so density, which is rho, is equal to mass all over volume. Of course, density is mass per unit volume. From here, if I cross multiply, mass times 1 gives you mass equal to density times volume gives you density volume. So that means mass can still be expressed as the product of density and volume. If I bring this into this equation here, you have that U, upthrust, is equal to, in place of mass, I'll put density times volume, and then we have what there? Gravity. So we can calculate upthrust by multiplying density with volume and then with gravity. Okay, so with this said, let's use this formula to solve this question, right? Upthrust equal to density, volume times gravity. So from here, we'll have that upthrust U it's equal to the density of the body is given by 1000, 10 to the power 3. So density 10 to the power 3 times volume. The volume is 60 cm cube. Now, the thing here is that the volume here is in cm cube. Okay, so we have to do conversion. Volume is equal to 50 cm cube. All right. This is cm cube. This is kilogram per meter cube. This is G in meter per second squared. So let's convert this volume here from cm cube to meter cube. How do we convert this? There's a shortcut. I could just give you a formula for this, but let me teach you how you do conversion. Now, here's how to do proper conversion. If I'm to convert from cm cube to meter cube, what do I do? Here's what you want to note. Recall that we said 100 centimeters from basic conversion. 100 centimeters make what there? 1 meters. We have this, all right? If I want to get cm cube, all I have to do is cube this part here and also cube this part here. This becomes 100 cube. So 100 cube. This cube also affects the cm here. It becomes cm cube is equal to, this cube affects 1. It becomes 1 cube. And then this cube affects meter. It becomes meter cube. Proceeding with this, I would have 100 raised to the power 3. And if you do that, that gives you 1 million. So 100, this 1, 2, 3. You have 1 million. Yes. So 100 to the power 3 gives you 1 million. 1 million cm cube. So 1 million here. Cm cube is equal to 1 cube here is 1. Then you have this one here. You have meter cube. So basically, this is the relationship between centimeter cube and meter cube. You want to note this relationship here. All right. Note this relationship. That is the relationship between centimeter cube and meter cube. Now, after this, the next thing you want to do here is that we are asked to convert from cm cube. So how do we do that? We know that 1 million, 1, 1, 2, 3, 1, 2, 3. 1 million centimeter cube is equal to 1 meter cube. We want to convert 50 in centimeter cube. Let's get the answer in x. We don't know the value. Let's call it x in meter cube. All I have to do here is cross multiply. 1 million times x gives you 1 million. 1 million x is equal to 50 times 1 gives you 50. To get the value of x, I'll divide here and also divide here too by 1 million. So 1, 1, 2, 3, 1, 2, 3. This one here, 1, 2, 3, 1, 2, 3. This cancels this. So x it's equal to 50 divided by 1 million. If you do that, your answer there is 0.0.00005. You have this. All right, so this is your answer. Of course, this x, the value here was in meter cube, as you can see at this point here. So it becomes this in meter cube. In essence, to convert from cm cube to meter cube, you divide by 1 million. That's the concept, right? I've just showed you how or why it's so. To divide this by 1 million, you have 0.12345 meter cube, right? You can also Google this. This is the correct answer. So I was trying to show you how they get this, just in case you have to do your own conversion. In essence, the upthrust U is equal to density 10 to the power 3 times volume 0.12345, then times gravity. Gravity is 10, so you have this. All right, so upthrust U it's equal to, I'll get my calculator, I'll punch 10 to the power 3 multiplying 0.12345, okay, then times 10. So the answer here is 0.5. If you do that, you have 0.5 as your answer. Upthrust, as you said, is a force, so it will be in Newton. So you have 0.5 Newton. That's the value of this. So if you look at that, that is option C, 0.5 Newton. That's your correct answer. All right, so that one done. Let's look at question number 42. 42 says, from the diagram above, calculate the energy stored in the capacitor, right? Let's get energy stored in capacitor. All right, so how do you solve that? We'll take this one off. Now you want to note that energy stored in the capacitor, 42, is given by E, and that's equal to half times charge times V, right? That's voltage. Half times charge times voltage. Looking at the question there is no value for charge there. You're given 8 microfarad, and that is value for capacitor or capacitance. C is equal to 8 microfarad. I know this is capacitance from the unit because it is capacitance that is measured in what there? Farad. Meanwhile, charge Q is measured in coulomb. All right, so since coulomb, that's C. All right, so since we don't have coulomb here, that's not charge. So is there a way we can bring in capacitance here? Yes, but we know that charge Q is equal to what there? CV. This formula exists. If I substitute this value of Q here with CV, I'll have that E is equal to half 1 over 2 times Q. The value of Q is CV, and then we have what there? V. So this is Q and then V. Multiplying this, I have half into C. V times V is V squared. All right. So E is equal to half C V squared. Let me take this part off. Okay. And that's equal to half into C. What's the value of C? C is 8 microfarad. Now, when we say micro, that becomes 8. Micro is 10 to power minus 6. That's coulomb. That's the charge in micro. So when we say 8 micro, simply 8 times 10 to the power minus 6. And then you have V. V is 10. So times 10 volts. So this times 10. V is squared here. So you can see it's squared. So I'm just going to square this square. And that's equal to, the point is you have your answer as, let's see, 0.5. That's half times 10 to the power minus 6 times 10 squared. You have your answer here as 0.0004. We're calculating the energy, right? Yep, energy. So that's in joules. So this in joules. Let's convert this to index form. This is equal to, from here, if I move 1, 2, 3, and 4, I need to move 4 times. So it becomes 4 times 10 to power minus 4. Since I have to move 4 times, then joules. So let's see if we have this option there. 4 times 10 to the power minus 4. Yes, we do. That is option B, this one here. So next up, question 43. 43 says a spring of force constant 1500 Newton per meter is acted by a curved force of 75 Newton. Calculate the potential energy stored in the spring. All right, let's get this. So for 43, you want to note that the formula to calculate potential energy, PE, is simply equal to half times F, force, times E, extension. This is the formula to calculate the potential energy on a spring. Now, let's look at what we are given. We are given force constant 1500 Newton per meter. So K is equal to 1500 Newton per meter. Okay, they said by a curved force of 75 Newton. So F is equal to 75 Newton. You have this. Right, so how do we get it? Because for us to get potential energy, we need the value of F and E. We already have a value for F, but not E, not for extension. So how do we get the extension? We recall that from Hooke's law, F is equal to KE. To get the value of E, extension, divide here by K, divide here by K, this cancels this. So the extension E is equal to F all over K. Let's impute values. This is equal to F is 75 all over K is 1500. If we do this, 75 over 1500, that's about 0.05. So I have this as 0.05. Extension is in meters. So from here, we can now get the value of potential energy, PE, as equal to half 1 over 2 times F. F is 75. That's the force. Times extension. E is 0.05. Let's multiply this. What do you have? Half times 75 times 0.05. You have your answer as 1.875, which is approximately 1.9. We are calculating energy. Energy is in joules. So you have the answer as 1.9 joules approximately. Let's see which option that is. That is option A, 1.9 joules approximately. So you have this. Question 44. A constant force of 5 Newton acts for 5 seconds on a mass of 5 kilogram initially at rest. Calculate the final momentum. So option A there, 125 kilogram meter per second. Option B, 25 kilogram meter per second. Option C, 15 kilogram meter per second. Option D, 0 kilogram meter per second. How do we solve this question? Now, in solving this question here, question number 44, the formula we use here is to recall that impulse is equal to momentum. All right. We've discussed impulse in our previous class. So check out our full JAMB playlist. All right. So you can see our class on impulse and momentum. Now, we said impulse is equal to momentum, typically because they have the same SI units. And we know that impulse is simply force times time. That's impulse, right? Force times time. That's impulse is equal to, well, not just momentum, but a change in momentum. So change in momentum. So force times time, which is impulse, is equal to change in momentum. That's P. We use P for momentum. Again, you want to record that but momentum P is equal to product of mass and velocity. So force times time for impulse is equal to change in mass times velocity. All right, change in mass times velocity. And if we put this in proper context, we'll have that impulse force times time is equal to mass. Change in velocity is simply final velocity minus initial velocity. That's u. So we have this. So multiplying this through, this would be equal to mass times final velocity minus mass times initial velocity. We have this. All right, so from here, we have force times time being equal to mass times final velocity minus mass times initial velocity. Looking at the question that they said initially at rest. When a body is initially at rest, it means that U is equal to 0. And if U is 0, we'll have force times time is equal to mv minus m. Initially at rest, U is 0. That becomes m times 0. That gives you 0. So it cancels out this equation. In essence, we'll have that force times time is equal to mass times final velocity. What you have here is the expression for final momentum. Right? So final momentum is simply mass times final velocity. We are asked to find this value. In essence, this value is simply equal to, that's final momentum is simply equal to force times time. What's the value of force? What's time? Looking at this, force is 5 Newton, right? The force there is 5 Newton, the time is 5 seconds. So if you multiply this, this is equal to force 5 Newton times time 5 seconds, and that's equal to what there? 25. And that's equal to 25 kilogram meter per second. So we have this. All right, so that's the value. Observe that we were not asked to find final velocity. If not, we would have divided this by mass. So 25 kilogram meter per second. The correct option there is B. All right, question 45 says, which of the following representation is correct for an atom X with 28 electrons and 30 neutrons? Now, how do we solve this? They give you number of electrons E as equal to 28 electrons, number of neutrons N as equal to 30. Right, you have this 30, this, and they say the element is X. All right, there's something called a nuclide symbol. A nuclide symbol of an element X is the symbol of that element showing its atomic number. So I'll put here as atomic number will be here, and then the mass number will be this one here, mass number. You want to know that atomic number is equal to number of protons. So let me call this AN. Atomic number is equal to number of protons. But in a case where you have an element that is neutral, now a neutral element or a neutral atom is an atom that does not have any charge. They gave you X, it was not plus 2 or minus 2. No, it was just X. Now the fact that this is just X without plus or minus means it's a neutral atom. And for a neutral atom, number of protons, P, is equal to number of electrons. And number of electrons is equal to, from the question, they give you 28. So that becomes 28 there. In essence, atomic number AN is 28. So here is 28 here. Then when it comes to mass number, let's call this Mn or atomic mass. Mass number or atomic mass is equal to proton plus neutron. And that's equal to the proton, as we've just said, is 28 plus the neutron. How many neutrons do you have there? 30. So plus 30. And if I add this up there, 28 plus 30, I have 58. So I have 58 as my mass number. This becomes 58. So my answer there is 58 up to the 8 down X. So that's option A. So that's the correct answer. Next up, 46. Which of the following 46, which is the incorrect formula for a body accelerating uniformly? All right, which of them is incorrect formula? A, V squared minus U squared over 2. That's not correct. B, V equal to U plus AS. That's not correct. C, S equal to half UT plus 80 squared. No, that should have been S equal to UT plus half 80 squared. So that's incorrect. D, V minus U equal to 2AS. That's also not correct. So here, basically, there's no correct option. Right? We're asking for incorrect formula. Literally everything here is incorrect if you know the equations of motion. So no answer here. No answer. All right. So you want to take notes. Perhaps it could be from the guys that typed this. Maybe they typed it wrongly. It could be. But looking at what we have here, there's no correct option. Okay. 47. Determine the focal length of a thin converging lens if the power is 5 diopter. Right? Focal length of a thin converging lens if the power is 5 diopter. So how do we solve this question here? Now to solve 47, you want to note that power of a lens P is equal to the inverse of the focal length. All right, that's how you solve this. And these two can switch position. That means focal length goes up. Focal length F is equal to 1 all over power of length. In essence, the focal length is equal to 1 all over the value of the power of the lens here is, let's say, 5 diopter. So P is 5 as we're given. So 1 all over P, which is 5. All right, so I'll get my calculator and punch 1 over 5. You have your answer as 0.2. Focal length is in meters, F. So the answer is 0.2 meters. Looking at the option there, you have B, 0.2 meters. So that's your answer. Next up, question 48. Which of the following cannot be used to measure the temperature of a substance? A, variation of pressure with temperature. B, expansivity of liquid. C, change in resistance of a conductor. D, change in color with temperature. So how do we answer this question? Option A there, variation of pressure with temperature is the property used by gas thermometers. So it's used by gas thermometers to measure temperature. So that can be the answer. B, talking about expansivity of liquid. Note that expansivity of liquid is used by bimetallic thermometers, and hence that's what they use to measure temperature. So that cannot be the answer. C, when we talk about change in resistance, you want to note that the change in resistance of substance is used by something called a resistance thermometer. In essence, option A here is used by gas thermometer to measure temperature. Option B here is used by bimetallic thermometers to measure temperature, while option C here is used by resistance thermometer. So the answer is D, change in color with temperature. That's the answer. All right. Question 49 says calculate the angle of minimum deviation of a 60-degree prism of a refractive index. Take the sine inverse of 0.75 as 49 degrees. So how do we solve this question here? Now, you want to know that you're given a refractive index of a prism, which is obviously a triangular prism. So how do we solve this? Now for 49, you want to recall the formula for refractive index. Now for a triangular prism, n, refractive index n is equal to sine of half a plus d all over sine half of a, sine half of a. So what we have here is the formula for calculating refractive index. Now, when they say minimum deviation of a 60-degree prism, what you have here, this value, 60-degree prism, is called the angle of prism, and that's simply A. So you're being given the value of A here as simply 60 degrees. So if you put that value here, we'll have that n is equal to sine half into A is 60 plus D all over sine half of A. A is 60. Let's proceed with this. This is equal to, I'm having this as sine into half of 60 plus D all over sine half of 60 is what there? 30. So I have this as sine 30. Again, you want to note that the value of n here is a constant, right? And for prism, the value of n is equal to 1.5. It's a constant. So what do you have there? N, which is 1.5, is equal to sine 1 over 2 into 60 plus d all over sine of 30. Now in solving this is of course all over 1. So it becomes this times 1. Sine of half into 60 plus d times 1 gives you sine of half into 60 plus d. This one here, it's equal to, this multiplies this, that gives you 1.5 sine 30. So we have this. All right. Proceeding from this, this becomes sine half 1 over 2 into 60 plus d. It's equal to, I'll punch 1.5 sine of 30. All right, that becomes half of 1.5, 0.75, 0.75. So I have this. All right, proceeding from here, of course, to solve this, next thing I have to do is take sine inverse. If I take sine inverse here, it cancels this sign. So I have 1 over 2 into 60 plus d is equal to sine inverse, all right, sine inverse of what I have here, 0.75. So that's how to eliminate sine from this part, right? Take sine inverse of both sides to cancel out this sign. Okay, I think they give us a value for sine inverse of 0.75. Let's check again. Take sine inverse of 0.75 here as 49. All right, so this is 49. So we are saying that half 1 over 2 into 60 plus d is equal to what there? 49. So we have this. So how do we solve this? Now, in solving this, of course, 1 times 60 plus d gives you 60 plus d all over your denominator here, 2. This is equal to what there? 49. Of course, this is over 1. Let's proceed with this. Let's proceed with this. This is equal to 1 times 60 plus d gives you 60 plus d is equal to 2 times 49. That becomes 49 times 2, which is what there? 98. To get d, I'll move 60 over to this point here. Becomes 98. 60 becomes minus 60. So 98 minus 60 gives you 38. So that's the value of d. So d there is 38. And your answer should be in degrees, of course. That's the angle of deviation, 38 degrees. All right, let's see what option there. Option A, 38 degrees. You also want to know that this is a constant, just in case, all right? The value of D is usually 38 or something close to 38, 37.5 also. Final question here. Question 50 says, what is the cost of running 740 watt lamps and 580 watt lamps for 12 hours if the electrical energy costs 7 naira per kilowatt hour? That should be this 7 naira per kilowatt hour. A, 80 Newton, B, 45.36 Newton, C, 65 Newton, D, 57 Newton. So how do you solve this question here? Now, to solve this, the first thing we want to do here is to get the total power. So question 50, let's get total power, right? Total power in watts, and that'll be equal to the number of lamps. They said 740 watt lamps. So it becomes 7 times 40. So it becomes 7 times 40 plus, okay, let me close this first. This plus the other one that we have what there? 580 watts. So it becomes 5 times the number of, so you have 80 watts, 5 of it. So total power here will be equal to, I'll just punch this directly and see what I have. So open a bracket, 7 times 40, close the bracket, plus, open a new bracket, 5 times 80. If I do that, my sum gives me 680. This is in watts. Now, looking at the question that they said, the cost is 7 naira per kilowatt hour. So we want to get kilowatts. So let's convert this to kilowatts. So the total power is equal to, in kilowatts, let me call this in kW. In kilowatts is simply 680 divided by 1000. All right, and that gives you 0.68 kilowatts. So the total power is equal to 0.68 in kilowatts. All right. Now they said, how long did you operate this? They say you operated this, or the operation of this particular electrical appliances was for 12 hours. So once you get the total time there, in essence, that will be equal to the total power 0.68 times how long it has been in use, which is 12 hours. Now, I'm not converting hours to second because this is in kilowatt hour. So kilowatt hour means multiply the power, kilowatts, times the time, hour. So it becomes times, the time then hour is 12. So we have this. And that's equal to 0.68 times 12. And that's 8.16 kilowatts hour when you multiply this. So when you multiply this, you have this. Now, if the electrical cost or the electrical energy cost is 7 naira per kilowatt hour, that means if you have 8.16 kilowatt hour, how much would you pay? You simply multiply this value by this amount here. So it becomes 8.16 multiplied by 7, since you charge 7 naira per kilowatt hour. So I have 8.16 times 7. That gives you 57.12. Of course, the charge is in naira, so you have this 57.12. So coming back to this, you can see that the correct answer there is D, 57.12 naira. Okay, so the correct answer there is D, 57.12 naira. All right, so this is how you answer this question. So with this, we are done with JAMB Physics 2022 questions. So in our next set of classes, we also provide the JAMB solution for physics, chemistry, mathematics, and biology between the year 2015 to 2025. So make sure you check daily for new classes. All right. Okay, guys. So please take note that we have a JAMB WhatsApp group for 2026 JAMB Bites. All right. So if you're writing JAMB for 2026, we have a JAMB WhatsApp group where we do daily revisions on physics, chemistry, mathematics, and biology. So if you're a science student and you want to join our JAMB WhatsApp group, I'll leave a link to the JAMB WhatsApp group in the video description. All right. You can also join our JAMB channel membership to get access to exclusive content for JAMB Bites. or you can get the full JAMB course on our website. Simply visit www.journalimmanu.com/courses and you see the JAMB/WAEC classes. All right. Okay, guys. So if you enjoyed this video, don't forget to hit the like button. All right. Like this video. Also leave a comment. Right. For the comment, I gave you a task, question number 11. Solve it, leave your answer in the comment section, and I will tell you if you're correct or not. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Then finally, ensure to share this video to your friends and their colleagues so that they can also learn. Thank you and see you in our next class.